So in the previous two tutorial videos, we learned about how you can create an array using two approaches. Either you can use the array initializer, or you can use create an array of certain size with all the default values stored 0 for the integer case, and also you can use individual assignment to assign to the different position one by one. So these are the two approaches we have to establish an array that looks like this, where the elements have no pattern that you can identify between the elements in the array. So now, for this particular video, we want to show you an interesting case, which happens quite often. In the case where you find that the values for the elements in the array can actually be patternized, in that case, you can use a for loop or while loop to actually initialize the array using a loop rather than writing them out individually. Okay, so now let me show you how you can do it. Specifically, let's use this particular array as an example over here. Okay, so we have this array over here. We're still going to call the array IA, standing for integer array. But now let's say we're gonna have an array just for illustration. Let's say we have an array of size 5. You can see for an array of size 5, always the starting index is 0. So that means the last index should be the size minus 1, which would be 4. Okay. So now let's try to see if there's any pattern we can identify for this particular array. Over here, you can see starting from 7, 10, 13, 16, and 19. So apparently this is an arithmetic sequence, which means there is a common difference over there. 7 plus 3, 10, 10 plus 3, 13, 13 plus 3, 16, 16 plus 3, 19. Okay, so there's a common difference over there. So now we can use this pattern property to actually use a for loop to actually initialize the array elements rather than, well, first, what you could have done, you can use approach 1. You can simply say integer array IA is assigned to, using the brackets notation, to enumerate 7, 10, 13, 16, 19. You can definitely do that, no problem. You can also use approach 2, where you simply just create an array of size 5, where each element simply stores 0 to begin with. And then you can say integer IA at position 0 is assigned to 7, integer array IA at position 1 is assigned to 10, and etc. You need to have 5 different assignments. That both approaches still work, as we covered in the previous videos. But now we want to show you 2 possible ways to really exploit such pattern between the elements. So now later on, for your application in the lab or in the lab test, as soon as you find out this might be some pattern for the elements in the array that you can exploit, you should really try to use a loop to actually automate the pattern. That can save you quite a bit of work. Okay, let's try to see how we can do it. I'm going to show you 2 versions for patternizing this initialization. I'm going to use 3.1 and I just called it 3.0 and 3.2. But anyway, I'm going to show you both versions. For the first version, I'm simply going to say the loop, for both versions, I'm going to use loop counter I. Okay, but now, the loop counter I in both versions means a slightly different thing. Okay, for the first version, loop counter I simply denotes the value that is going to be stored, which means I'm going to initialize my loop counter to be 7. Okay, on the other hand, in the second version, the loop counter I simply means which term in the arithmetic sequence you're going to denote. In this case, I'm going to initialize the loop counter I by 1. Okay, 7 versus 1. Okay, that's an interesting bit, but both programs are going to achieve the same thing. They're just equivalent. Okay, let's try. So now, first of all, let me create integer array. Let's say 3.1. How about that? So new class integer array 3.1. Oh, actually, apparently I cannot say dot. So now 3_1. How about that? Okay, or we can say 3a. Okay, I think that'll be better. How about 3a? And then generate the main method over here. Okay, so now first let's try this. Okay, what I would do is I'll simply say integer array, and the name is simply IA is assigned to a new integer array of size. In this case, it will simply be 1, 2, 3, 4, 5. Okay, as we learned from the previous tutorial video, after executing line number 5, every element in array IA is simply just going to be 0, the default value. Okay, so now I'm going to use a loop to actually initialize the all the elements. Okay, let me propose the following. As I said, for version number 8, the loop counter I is going to be initialized to be 7. And now, how do we update the loop counter I? We can say I plus equal 3 to say the first iteration I is going to be 7. For the second iteration, I will be incremented by 3 rather than I plus plus, the usual case, right? And what should be the state condition? I'll say as long as I is less than or equal to the last term, which is 19, then I should stay in the loop. Okay, let's try. I can say, let's say, in this version, the value of loop counter I denotes the value to be stored at the array. Okay, that's something we want to have. Okay, and I'm going to use a little bit of trick over here. Okay, and we might need another variable over here called j. Okay, let me just try. Let me do that for you. Okay, so now for integer I is assigned to 7, and then I less than or equal to, in this case, it will be 19, right? 19 is last term. 19, and then I plus equal 3. Okay, I plus equal 3 over here is simply equivalent to I is assigned to I plus 3. You can write that as well. Okay, it's completely up to you, but I'll just write it a little bit in a shorter form. I plus equal 3. Okay, over here. And now I want to say for every iteration, I'm going to store the value, right? I want to say IA at position something, I'm going to store exactly the value for I. Okay? But now the question is, what should the question mark be? The position. I might need another helper variable to help me. Okay? So now let's try the following. Okay? I can simply declare another variable here. I can say integer j is simply 0. I'll make a note, comment for you. Index of the array. Okay, so now I can simply say j over here, and then at the end of the iteration I can say j plus plus. Okay, it looks complicated, but it's not that complicated, but we'll see exactly how things will go. Notice that the state condition for the loop over here is simply I less than or equal to 19. Somehow this is going to make sure j will never become too large as an index for the array IA, but we'll see exactly how it is going to run. Okay, the way we set it up will just work, but I think the first version is a little bit just for illustrating how things can be done in one way, but the second version 3B that I'm going to show you later is going to be the version I will recommend to you. Okay, but let's try just for I think it's going to help your programming skill anyway. So after this, of course, I'm going to simply print out the array element one by one. Let's double check as well. Okay, so now let's simply say, so now how do we print out the element one by one? Print out the element of the array one by one. Okay, that's what we'll do, and we learned that very well from the previous 2 tutorial video. I'll just write it out. For integer I, by the way, you can see that I can also declare I again because, as I said before, because I is inside the header of the loop, so the scope for this I is only within this particular for loop. There's no conflict with this particular I over here. Okay, I is initialized to be 0, I less than IA dot length, and then I plus plus. Okay, and we know very well how to trace this particular block of code. We did that in the previous tutorial about how to use iPad, how to use a table to trace manually, how to use debugger. Please review the video if you have doubts. Okay, so now over here we're going to say system.out dot print line over here, and then I'm going to say elements of IA at index I is, and then IA at position I. Okay, something like that. So now let's try. Okay, so now if I go back to a package explorer and then right click on integer array 3A, and then I say run as, Java application. So what I get is, I simply get 7, 10, 13, 16, 19. 7, 10, 13, 16, 19. Okay, that works. Okay, everything works perfectly. Okay, but now we want to know why this block of code is going to do the trick. Okay, that's something we want to see. Okay, so what I would do is, I will simply just copy the lines of code and then I'll trace it on the iPad using a table with you together. Okay, so now it's really important for your understanding for version 1, and then we go to version 2. Okay, I'm gonna copy this particular block of code and then I'll paste it to my iPad. Okay, this one here, starting from the initial array creation. Okay, so now let me move on to a new page over here. So this will be version 3.8. Okay, so now I'm gonna paste it over here. Okay, this is the block of code we have. Let me make it a little bit bigger. Okay, hopefully that's visible to you. Okay, so now let's trace it. Okay, so now let's do the easy one first. So what happened for this line? When we execute this line over here, we're declaring an array variable called IA. So that means IA over here is going to point to an array of size 5. Okay, so this is how you draw it. So of size 5. So 1, 2, 3, 4, 5. Okay, indices 0, 1. You know what? Let me use a different color to tell you what the indices are. 0, 1, 2, 3, 4. Okay, so now IA, the length will just be 5. Okay, and then the value will just be default 0, 0, 0, 0, 0, as we explained in the previous video. Okay, that's for this particular line. So now let's try the following. Okay, so now what we will do is we're going to trace the rest of the line one by one. Okay, so now first of all, we have this particular line over here. We simply initialize a variable called j. So I will put j over here. Okay, j over here, initial value is simply just 0. Okay, and then we have another variable, so now we try to enter the for loop. So we initialize the loop counter I to be 7. I over here is simply the value 7 over here. So now we're gonna draw a table. Okay, so now you know what? I think to draw the table, let's draw it this way. Let me use blue over here. Okay, let's have a table over here. So we're gonna have the value for the loop counter, and also the value for the state condition over there, and also the value for whatever the loop body, the important expressions. In this case, we're gonna trace the following. Okay, so now we're gonna have over here, what's the value for I, and what's the value for, you can see the I, the loop counter over here, and also what's the value for the state condition, I less than or equal to 19. Okay, and remember at the end of each iteration, we're going to say I plus equal 3, and also we're going to say j plus plus. So these are the two updates that are important to do. Okay, we'll make sure we do that. For this particular line over here, we're going to care what's the IA, j, that will become. Okay, IAJ is assigned to I. Okay, so this is the assignment that we're going to perform for every iteration. Okay, so we're going to see. Okay, I think you know, so for this part here, since we already got a diagram in the light blue, so we don't need this part here. All we need to do, I think that'll be enough. Okay, that's enough. And then we don't need this box either because we already got a column over there. Okay, I think that'd be enough. That's the best way. So you don't necessarily have to put every information in the table. You can have a combination of diagram and a table as long as they together make sense. Okay, I think this will make sense now. Okay, so now let's try the following. So now initially you can see the value for I is 7, right? So I'll put 7 over here. So that means I have to evaluate this state condition here for the first time. 7 less than or equal to 19 is going to give me true over here, right? So that means I'm going to perform this particular assignment over here. So what am I trying to do? What I'm trying to do over here is I'm going to do over here, you know what? I changed my mind. Okay, I can always change my mind, of course, when I try to change my code. So now when I say over here, okay, so now let me just do another one here. So the body over here simply says I should do IA at position J is assigned to I. Okay, so what does that mean in this case? So that means I'm gonna do IA at position, and we know the value for J is currently 0. At position 0 is assigned to the value of I, which is 7. Okay, agree? Okay, so now what does this assignment do? At position 0 over here, I'm going to assign that to 7. Okay, rather than storing 0, it's going to store 7 instead. That's what this body of the loop will do. Okay, it's really important for you to follow the first one. Okay, all the others will be repeated. Okay, and then at the end of the loop, we're going to do J++, which means it's going to be, rather than 0, it's going to be 1. Okay, and then we're going to do I plus equal 3 over here. So that means it will be incremented from 7 to 10. Okay, after that, we're going to evaluate the header of the loop again to see if I less than or equal to 19 is going to be satisfied again. Right? So we're going to see 10 less than or equal to 19, as we know, is going to be true. Okay, so what this will boil down into is we're going to execute the body of the loop for the second time. So what we'll do is going to say IA at position J, and J value at the moment is simply just 1. At position 1 is assigned to the value for I is 10. Okay, 10. So what does that mean? Position 1 is over here, and we are trying to reassign that to this particular value, which is 10. So rather than having 0, it's going to be 10. Okay, so far so good. Okay, let's speed up a little bit. And then we're going to have execute J++, which is going to be from 1 to 2. And then we're also going to execute I plus equal 3, which is going to, let me just, so you don't really lose that particular updates, okay? So I large plus equal 3, so that will go from 10 to, you will go from 10 to 13. So now 13 less than or equal to 19. So we're going to evaluate this for the third time over here. So it's going to be, again, true. Okay, that means we're going to execute the body of the loop for the third time. Okay, so now what's going to happen is we're going to have IA at position J, right? J over here. So J is currently of the value 2. So at position 2 is assigned to, now for the value of I, the value for I is simply 13. So now 13. So now position 2 is simply here for IA, and then reassign to this particular value, which is 13. Okay, hopefully so far you get an idea. Let's, before completing it, let's finish that. Okay, so now let's try the following. So now we're gonna increment the J over here from 2 to 3. Okay, you can see the value for J simply tells us which position to go to change the array. Okay, which position in the array to go to. And then we're going to execute this particular I plus equal 3 over here, which means we'll go from 13 into 16. Now 16 less than or equal to 19 is still going to give us true over here. And then we're going to have the body of the loop being executed for the fourth time. So now we got IA at position. So now what should be the position? Well, the value for J over here, right? For value for J is simply 3. At position 3 is assigned to, it should be the value for I. Okay, the value for I is simply 16. Okay, index 3 over here, okay? And then it's going to reassign to this value 16. So now it'll be 16. It seems like we got one more iteration to do. Let's do it. And then we'll see how exactly we're going to exit from the loop. And then we're complete. So now, okay. So now we're going to, at the end of the loop, we're going to execute J++ again. So now J will be incremented from 3 to 4 over here. And then we're simply just going to execute I plus equal 3 again. So we'll go from 16 to 19. Okay, so 19 less than or equal to 19 is also going to give us true. That means we got one more iteration to do, maybe just one more. So now, how do we do it? So now, the way we do it is going to say IA at position J. In this case, it is 4. Okay, at position 4 over here is assigned to. So now the value for I is 19 over here. Okay, so now position 4 is exactly over here, and now we want to reassign that to 19. So now reassign that to 19. Okay, what to do? And now what we have to do now is we have to, at the end of the iteration, we're going to say J++. And now 4 to 5. Notice that 5 is no longer a valid index for IA, right? The largest index seems to be just 4. But now 5 should not be used as an index for the array. However, we don't have to worry because the state condition is being set up properly. The state condition here. Let's see exactly how. Okay. So now after this, don't forget we also have to increment I by 3. So now from 19 to 22. So now when we evaluate this particular state condition for 1, 2, 3, 4, 5, the 6th time. So we're going to get 22 less than or equal to 19. So what do we have in this case? Well, apparently we have false. As soon as we have false over here, that means we're going to bypass the body of the loop and then just exit from there. Okay, that's how we exit. Okay, so now that means we're done. We're never ever going to use the 5 over here as an index into IA. So we never get into array index out of bound exception. Okay, so we are done. So notice that again, you can see it's a very important pattern for you to observe for the for loop. You are just going to execute the body of the for loop as long as the state condition evaluate to true. And now as soon as the state condition evaluate to false, you don't really repeat the body of the loop anymore. Okay, that's for the first version. Okay, hopefully you can see exactly how that works. Okay, so now what I would like to do is I want to show you the second version, but for the first version I think it's really worth for you to understand as well, because we're using 2 variables that's being updated for each iteration. It's a very nice case study for you at the moment, so please study that, even though I personally more recommend the second version, which is more general solution for you. Okay, so now for the second version, what I will do is, so what we have just done is the first version over here. For the second version, I would like to use the value of I to denote the turn. Maybe when let's say I start with 1. Okay, I will start with the value for 1. Think it this way. So now let me think about a formula. Let's think about math, right? So again, don't forget, programming is highly based on math. Okay, so whenever you want to figure out, especially for for loop or for loops iteration in general, if you want to figure out exactly what you have to do, you have to think mathematically. Okay, so now let's say this. If I say the loop counter denotes the ith turn in the arithmetic sequence, so we know that the first turn. Okay, let me make it a little bit thinner for me. Okay, you can see the first turn, the second turn, and the third turn. Okay, actually, you know what? Let me put it this way. So now if I just do a little bit table over here, if I got a turn over here, and also the turn can be 1, 2, 3, 4, and 5, right? We got 5 different turns. Okay, so now we know that the value for the turn should be 7, 10, 13, 16, and 19, right? So now let's be a little bit more careful when we draw the table over here. Okay, so now, okay, let's see exactly how we can figure out a formula for that. Okay, so now this will be some formula. Okay, let me use a different color here. How about that? So now, what would be the formula between the turn number over here and the actual value that is stored? Okay, when turn is actually 1, we got 7. Okay, when turn is actually 2, we actually got 10. Let me propose the following formula. Okay, so now the formula would be the value will simply, let me talk about just math only. Value will be the turn that you talk about. We know the base turn is simply just 7, right? Plus the turn minus 1 multiplied by the common difference. Okay? Yeah, it's not complicated. Come on, right? So let's try to see if that will work. Okay? So now let's try this. When turn is simply just 1, 1 minus 1 will give you 0. 0 multiplied by 3 will give you 0. 0 plus 7 will just give you 7. So that'll be 7 plus 0 times 3. Okay, what about when turn is equal to 2? In that case, you got 7, which is the base turn of the first term, plus, okay, now 2 minus 1 will give you 1. So that'll be 1 minus 1 multiplied by 3. You also got 10, right? Also 7 plus, and now you got turn is simply 3. So 3 minus 1 will give you 2. So that means you got 2 multiplied by 3. That means you got 13. When turn is actually 4, so 7 plus, so now 4 minus 1 will give you 3. So 3 times 3, which will be 16, right? And also, finally, when turn is equal to 5, 5 minus 1 will give you 4. 4 times 3, okay, 7 plus, okay, 4 minus 1 will give you 4 times 3. Right? So the formula works. Okay? Of course, over here, if you don't quite like the turn minus 1 over here, it is okay to say, what about we simply start a turn rather than saying turn 1, 2, 3, 4, 5. You can alternatively, you can say the following. Okay? I'll give you alternative version. You can say the turns number is simply 0, 1, 2, 3, and 4. In that case, you can simply say the value will simply be 7 plus the turn multiplied by 3. That will also work. Okay, I will let you double check with the formula. So now, if you want to use a green version of the formula, the turn number over here for the loop counter must start with 0. If you want to use a red version over here, the turn over here should really start with the loop counter I being 1. Okay, either way. But maybe I'll put down both for you. Okay, but now we'll only trace one of them. Okay, hopefully you can see kind of the mathematical analysis over here. It's not difficult, right? So now let's try the following. Let's now do another array class. Okay, I'm just gonna copy 3a and then make some modification over there. Okay, I'm gonna say copy. Okay, right click on the class and say copy, and then right click and then say paste. Okay, so I'm gonna say 3b. Okay, for 3b, I'm gonna show you two versions. One will be using the green formula, the other one will be using the red formula. Okay, both work. Okay, so now in this version, okay, so now we are in 3. Oh, sorry. Let me close that, otherwise I will be confused. Double click on the version 3b. Okay, let me also clear the console. Right click and say clear. Okay, so now what we'll do is, so now in this version, the value of loop counter I denotes the turn sequence number in the arithmetic. Okay, turn number. Turn number. It can be turn. You can either calculate turn as turn 0, turn 1, turn 2, turn 3, turn 4, or you can say turn 1, turn 2, turn 3, turn 4, turn 5. Right? Depending on when to start a turn number with 0 or 1. Okay, you're gonna apply a different formula. Let's try version number 1. Let's try the green formula first. Okay, the green one. So the advantage. Let's try this. The advantage for this second version here, I don't necessarily need two counters. I don't need two counters. In the case of 3a, remember we need both I and j, right? But now I don't. I can get along with just just variable I. Okay, let's try this. For integer I is initialized to be 0. That's a turn number. Okay, I less than or equal to. Okay, so now I know that it's going to be turn 0, turn 1, turn 0, turn 1, turn 2, turn 3, turn 4. Okay, turn 4. And then each time I just go from one term to another. Okay, so now let's apply the formula. Okay, and at the same time, I can be used as the index for the array, starting with 0, right? And also it's incremented by 1, so I can conveniently use it. Okay, but I'm gonna trace it together. Okay, so I can say IA at position I is simply assigned to. Now what should I do? You can see the value is simply 7 plus. Okay, and the term number in this case simply I multiplied by 3. Why don't we try? If I simply right click on integer array 3b, I can say run as Java application. Okay, I got 7, 10, 13, 16, 19. It works. Okay, let's try the second one. I think I should really trace both versions with you just for completeness. I really want you to understand the logic over here. It's really important for computational thinking. So now for version number 2, in this version here, the term number starts with 0, and we use the following formula. Okay, we can say the value for this particular term is exactly equal to 7, which is the starting term of the arithmetic sequence over here, plus the term multiplied by the common difference. Okay, and now let me try the second version. In this first version over here, so now temporarily, can I just, oh actually, you know what, maybe I should just okay, keep both versions active over here. Okay, what I should do is, what about I simply say this? Okay, you know what, I think to really make it clean, why don't I recreate 3C? Okay, how about that? Okay, so now let's say we right click on 3B and then we say copy, and then we'll say paste, and then we're gonna say 3C over here. Okay, so we got 3A, 3B, and 3C. So now 3C in this second version over here. Okay, the value of 3C, the value of loop counter I denotes a term number in the arithmetic sequence. Here the term number start with 1, and we use the following formula. Value is simply the same as 7 plus term minus 1. Right? That's something we agreed before, right? On the iPad, right? It's term minus 1. That's exactly the table I'm trying to use over here to help you trace. Okay, and then I'm going to say I is simply just going to be 1. And then since we got 5 terms, so 1, 2, 3, 4, 5, I can say I less than or equal to 5. But now be careful. If you want to use I over here, you cannot, because I will be 1, and then 2, and then 3, and then 4, and then 5. 5 less than or equal to 5 is still true. But if you use I equal to 5 as an array index over here, 5 is out of boundary. So if you try to use IA at position 5, it's going to give you array index out of bound exception. So now the trick you have to apply will be I minus 1. Okay, that's why I also want to trace it together with you. Okay, it's really interesting. You really want to get used to playing with the array indexing expression over here. And then I can say 7 plus I minus 1 multiplied by 3. Okay, I minus 1 term minus 1 multiplied by 3. Okay, so that's kind of the second version over here. Which version you want to use is completely up to you. Let's make sure it works. Okay, so now 3C, if I right click on 3C and then I say run as Java application. Okay, so you got 7, 10, 13, 16, and 19, right? So that also works. Okay, so now let's trace 3B and 3C all together, right? Okay, so now eventually what you want to do is you really want to go through these two approaches, right? Remember the very first approach, which is 3A, right? And then for the second approach, we got 3B and 3C. Okay, so now let's just close everything here. So now let's try 3B first. I'm going to first of all copy the code over here. So now let me copy this fragment of code over here, and then we'll trace it together and see if that would actually give us the right answer. We already see from the console that actually does produce the right output, but we're going to trace to see how exactly that works. So this will be 3B. Okay, let's do 3B first, and then we'll do 3C. Okay, let's try. So now let's maybe first of all paste the program over here. Okay, over here. Okay, good. So this is 3B. Okay, let me just put the notes over here. So this is 3B. Okay, so now let's try to trace it. Number one, so you can see when we try to execute this line over here, we're simply going to initialize an array of size 5. So IA is going to point to an array of size 5 over here. 1, 2, 3, 4. Actually, not so good. 1, 2, 3, 4, and 5. Okay, for indices, I'm going to put 0, 1, 2, 3, and 4. Initially, all the values would just be 0 initially, right? 0, 0, 0, 0, 0. Default values. So now let's try to trace this particular for loop over here. Okay, let's see exactly. We only have one loop counter, but now let's be very careful because it seems to be a little bit complicated over here. Okay, so now actually this one is not complicated. 3C would be more complicated, but let's try. So it's good that we do this version first. Okay, so what expression do we want to trace? We want to trace for the value for I. We want to trace for the state condition I less than or equal to 4. And also we want to trace for what's going to happen when we say IA at position I is simply assigned to 7 plus I multiplied by 3. We want to see exactly what's going to happen over here. Okay, so now everything will just be very obvious once we started tracing. So this way of tracing using a table is very powerful by using hands. Okay, so please try to pick out the scale. Okay, so now what we'll do is we simply have a table over here with 3 columns. Okay, so now let's try. Eventually we should expect to see we should have 5 rows where the state condition evaluated to true. That means we got 5 iterations to be executed, and the sixth time that we try to evaluate the state condition, it should become false, which means we don't try to execute the body of the iteration anymore and exit from the loop. That's what we can anticipate from the previous experience. Okay, let's try. Okay, number 1, let's use green. Okay, so now for the very first time, we simply say I is initialized to be 0 over here. So now we're going to evaluate this for the very first time. So 0 less than or equal to 4 is going to give us true. Okay, so what should we do over here? What we should do is IA at position I's value is 0 is assigned to 7 plus I is 0, 0 multiplied by 3. So what does that mean? So this part over here, the value is simply just 7, right? So now I'm going to store 7 into position 0. Position 0 is over here, so store 7 into it. Okay, let's use a different color. So what about the second iteration? And now at the end of the iteration, we're gonna that iteration, we're going to say I plus plus, right? So now the new value for I would just be 1. Okay, and then once we go for 1, we're gonna evaluate this state condition again for the second time. So that means 1 less than or equal to 4 is going to give us true. So what should we do now? We should say IA at position, right? We also have I over here. I is simply just 1. Okay, at position 1 is assigned to 7 plus. Okay, so now I multiplied by 3. I is simply just 1. 7 plus 1 multiplied by 3. And what's this value over here? Well, that's hopefully you can figure out, right? It's simply just 10. So that means we're going to store 10 into position 1. Position 1 is over here, and store 10 into it. Okay, let's just go on for completeness. And then we have pink over here. So now we're going to at the end of the iteration, we're going to actually increment I by 1. So now that means it's going to be 2. Okay, so now we're going to evaluate this particular state condition here for the third time. So 2 less than or equal to 4 is going to be true. And then we're going to evaluate IA at position I over here, which is going to be 2, is assigned to 7 plus I multiplied by 3. Oh, sorry, I in this case is simply just 2. 2 multiplied by 3. In this case, you can calculate is simply 13, right? So store 13 at index 2. Index 2 is over here. Store 13 into it. Okay, so far so good. Let's continue with another iterations. So now let's use blue. Maybe use how about red over here. And then I'm gonna have over here. I'm gonna at the end of the iteration, I'm gonna increment I by 1. Right? Don't forget, you always had to update the loop counter. Okay. So now I'm gonna increment from 2 to 3. So now it's gonna be 3 over here. So now 3 less than or equal to 4 is going to be still true. So what we get is, okay, so I really meant to use a different color. I think that'll be better. Okay, so now I think it's going to be 3 over here, and then 3 less than or equal to 4 is also going to be true. And then what we can evaluate is IA at position I. So IA at position 3 is assigned to, and then 7 plus I, which is 3. 3 plus 3. And in this case, it's going to be 16. Okay, so store 16 into position 3 of the array. Position 3 is over here, and store 16 over there, right? That's what we'll do. At the end of the iteration, we're going to increment I by 1. Okay, so that means it's now going to become, let me say green, this green, or how about this? It's going to become 4 over here. Okay, so now 4 less than or equal to 4, still true. Okay, so now we're going to do the 5th time. So now what we're going to do is IA at position, you can see I over here is going to be 4, is assigned to, so now 7 times I, 7 plus I is 4 multiplied by 3. So now you can see that it's simply just 19, right? You can see this calculation here is simply 19, right? 19 is going to be stored at index 4. Index 4 is over here, and then you're going to store 19 over here. At the end of the iteration, you're going to increment I further more by 1. So now finally, what we're going to get is great. It will go from 4 to 5 over here. As soon as it's 5, though now what should we evaluate? I less than or equal to 4 is going to be 5 less than or equal to 4 is simply just going to be false. Okay, as you can see again, you can see for the very first 1, 2, 3, 4, and 5 times, the state condition is simply just true, which means we execute the body of the loop for 5 times. And then for the very final time, it simply becomes false. As soon as the state condition becomes false, we're going to exit from the loop. Okay, so now you can see that we successfully reassign that to 7, 10, 13, 16, and 19. Okay, that's why when you see from the program, it actually works. Okay, hopefully it makes sense to you. Okay, this is 3B, and I think we still need to trace 3C for completeness. I'll do that. Okay, let's be patient here because I think for learning, you really want to be precise and complete. Okay, let's try to do it all together. Okay, of course, you can pause the video for now, try to do the tracing for 3C, and then once you're done, compare your paper with what I'm going to do for 3C. But let's do it. So now what I will do is I will double click on integer array 3C over here. Let's try to trace it. Okay, so now what you will do is let me copy the program over here. Okay, so now I'm simply just going to copy this part of the code over here. Okay, this will be very interesting to trace because you got more complicated expression over here, for example like I-1, but you know it's not that bad. Okay, so, okay, we just need to gain experience on doing this. Okay, let me add a new page over here, add a page below, let's cover template. Okay, let me just paste it. Okay, we simply just put it here. Let me make it a little bit bigger for you. Okay, let me make it a little bit smaller here. Okay, so now let's do it. Okay, so now there are many things that will be very similar. So if I can speed up, I'll try to speed up. Okay, so now for this line over here, we're simply just going to have an integer array IA, which is pointing to this particular array, this new array of size 5. Okay, I'm gonna put it here, 1, 2, 3, 4, 5, and then the indices 0, 1, 2, 3, and 4, and the element will simply just be 0, the default value to begin with. Okay, so now we're gonna try to execute this loop over here, right? Let's say for the very first time, and what should we trace? Let's say we try to trace the value again for the loop counter I. Okay, let me just give you a little bit more space. Try to trace the loop counter I, and also the expression I less than or equal to 5. And then we want to really calculate what is I minus 1. There's a reason for that, because you can see I minus 1 is used over here and also used over here. Okay, so I'm going to separate out. And also we're going to see the loop body is going to be IA. I minus 1 is assigned to 7 plus I minus 1 multiplied by 3. Okay, it's really important to trace this. Okay, so now let's try that. Okay, let's draw the table, get it ready. Okay, and then we got all the way here. We got all the way here. Okay, second column and third column. Okay, let's try. So for the very first iteration, we're going to initialize the loop counter. Okay, let's try the first one. Okay, let me try that. Okay, so now for this one here, so I is going to be initialized to be 1 over here. So now 1 less than or equal to 5 is going to be true, right? So now I'm going to evaluate this for the first time. It's going to be true. So that means we're going to go into we're going to go into the body of the loop. Okay, now at this point, what's I minus 1? I minus 1 will be simply 1 minus 1 will be 1 minus 1, which is 0. Okay, you can actually see that very clearly, right? I'll just put 0 here, right? Because 1 minus 1, which will be 0. So now that means this body of the loop is going to be boiled down into IA at position. Now I minus 1 is 0, is assigned to 7 plus I minus 1, which is 0, multiplied by 3. This corresponds to exactly the first row in 3B. Okay, so now what do we do? Well, exactly this value over here will just be 7, and then to store in position 0. Position 0 over here, and then we're going to store that into 7. Okay, the same thing. You can see even though the starting point for I is different compared with 0 over here, and also the state condition is different compared with this over here, and also the body of the loop is different compared with this, but the effect will just be the same. That's the interesting part for programming. Okay, so now let's try that. Okay, so now let's try the following. So now let's try the at the end of the iteration, we're going to say I plus plus. Okay, so that means I will be incremented from 1 to 2. Okay, so now we're going to say 2 less than or equal to 5 is just going to be true. That means we're going to execute this particular body of the loop for the second time. Now I minus 1 will just be 2 minus 1 will be 1. Okay, so that means over here we're going to say IA at position 1 is assigned to 7 plus I minus 1, which is 1, multiplied by 3. Okay, we know very well this should be 10. So store 10 into position 1. Store 10 into position 1. And then we're going to increment the value of I by 1. So now increment that into from 2 to 3. So now we're going to evaluate this particular state condition again. So 3 less than or equal to 5 is going to be true. Okay, that means we're going to execute this body of the loop for the third time. So now what's I minus 1? 3 minus 1 will be 2. So that means I minus 1 here. So IA at position 2 is assigned to 7 plus I minus 1 is 2. 2 times 3. So now we got simply 13. So store 13 into position 2. Position 2, store 13 into it. So far, so good. At the end of the iteration, we're going to increment I by 1. So that means we increment that to from 3 to 4. Okay, so now when we evaluate this state condition again for the fourth time, 4 less than or equal to 5 is going to be true. Okay, and what about I minus 1? I minus 1 would be 4 minus 1, which is 3. So now when we evaluate the body of the loop over here, we're going to have I minus 1, which is 4. So IA at position, sorry, I minus 1 is 3 over here. I circled the wrong thing. Okay, it should be at position 3 is assigned to 7 plus, and then I minus 1 over here, which is 3 times 3. In this case, it will be 16, right? So that means we store 16 into position 3. Position 3 and store 16 into it. It seems like one more iteration to go. Let's do it. Okay. So now we want to do another one. Let me use maybe green over here. Okay. So now at the end of this iteration over here, we're going to execute I plus plus over here, right? You can see I plus plus over here. So now it's going to be incremented from 4 to 5 over here. So now 5 less than or equal to 5 is going to give us true. Okay. So now that means we're going to go into the body of the loop for the fifth time. Okay, so now what's I minus 1? I minus 1 will be 5 minus 1 will be 4. So now that means here I minus 1 is going to be IA at position 4 is assigned to 7 plus I minus 1, which is going to be 4 multiplied by 3. Okay, so this value over here is simply just 19, right? So store 19 into position 4. Position 4 over here, store 19 into it. Okay, seems like we are done, but we're not sure yet. Now, at the end of this particular iteration, we're going to, again, execute the update part for the loop. So now that means we're going to increment the loop counter I from 5 to 6. So now we're going to say from 5 to 6. So now when we evaluate the state condition again, 6 less than or equal to 5 is going to be false, right? So that means we don't actually try to go into the loop. So we're gonna bypass this part over here and then exit from the loop directly. Okay, that's how we avoid having an infinite loop with a proper state condition. Okay, again, as you can see the pattern over here, what we have over here is, you can see for the very 1, 2, 3, 4, 5. For the very first 5 checks on the state, sorry, highlighted the wrong thing. For the very first 1, 2, 3, 4, and 5. For the very first 5 checks on the state condition over here is simply true. That means we execute the body of the loop 1, 2, 3, 4, and 5 times. And then as soon as the state condition becomes false, that means we simply stop executing the body of the loop. Okay, so now again, it's really important for you to see for this particular video here, you can see the actual coding part is not many lines. However, the way we tweak the logic is really important for you to understand exactly why we can go from one version to another. Okay, so now really please make sure you understand exactly how we did the version A over here. Okay, for version A, we did it here, and also for version B and C, we did it here with some formula. You want to understand all the 3 versions, and we did the tracing for all the 3 versions very carefully together with you using the tabular notation. Okay, if you go back to the coding over here, to make sure you know all the 3 versions, of course, each of the versions worked, but if you really ask my personal advice, which one should you really try to adopt? I would say maybe try to get more comfortable with either version B or version C. So these are more general solutions for you to apply to other similar problems. Again, the lesson to learn is whenever you see that your array elements have if the values to be stored into your array has certain pattern that you can observe. In that case, you don't really have to have just a separate assignment to initialize them. You can simply use a loop to initialize them. That's actually a much better way to do it. Let's say if I want to initialize an array of arithmetic sequence of size 1000. In that case, well, I'm afraid you just don't want to use approach 1 or approach 2 to like either an initializer or to use separate assignments. That's not what you want to do. You want to use a loop which will simply iterate through 1,000 times for you. The code you have to write will be the same line of code. Okay, so that's really the lesson to pick up from this particular video. Review all the concept and also how we trace the program before you go to the next one.